In the previous video, we talked about developing a base rating curve. Now, I conveniently ignored certain measurements that were falling off my rating curve due to scour and fill, and I ended the previous video talking specifically about measurement 59. If I right-click on that, we're going to see that that's an aggregation on top of the control feature, and it's an enormous error away from the base rating curve, 40% error. And there are a few other measurements that are falling on the same side of the rating curve. This one's also aggregated, 21% error associated with it. This one is also aggregated, 63% error, really falling away from the base rating curve. Now, typically, measurements that are subject to scour or subject to fill will fall in two different directions away from the rating curve. In fact, there's only one real control condition change that will push measurements below your rating curve, and that's scour out. Essentially, we're getting a lower gauging pool behind our control for a correspondingly higher flow value. So that would be equivalent to a measurement right here. And what do you know? Right there, scour on this particular measurement. So what I'm going to do is look at my measurements relative in time and see which ones have scour associated with them and which ones have which ones have aggregation of the control. So to do that, let's look in the site visit data pane and let's sort by control condition. And I just want to switch on my aggregated measurements. Now this one's clear, so I want to switch that one off. That one's also clear. Flood measurements aren't going to be important, especially when we're dealing with low-end flows. And we've got some scour measurements down here at the bottom. So I've just switched on my measurements that fall off the curve. And you can see here, indeed, those are the measurements that are falling off the curve, and they're falling in the correct directions. Now let's look in our time series view over here. And you see that my measurements, my green measurements that fall below my base rating curve, they're the scour measurements. They're on the rising limb of this hydrograph. And my fill measurements over here, aggregation of the control, fall on the falling limb of the hydrograph. Now this is very typical. When you have a rising limb of a hydrograph, it tends to scour out, and then on the falling limb of a hydrograph, you tend to get fill on the control feature. So in this particular case, we're probably going to deal with two shifts, and we're going to shift in between this peak on the hydrograph and then back down. So to do this, we're going to start in the shift manager. And I don't have any shifts here, that's why most of the controls are actually grayed out, but I'm going to start by inserting a shift. Yes, I do want to insert a shift. Now the start date for this particular shift is something we're going to have to look at very judiciously. So the start date on this particular shift is probably the start of the rise of the hydrograph. So in this case, maybe around September 2004. So I'm going to go to September. I'm going to start it on the 1st. We can adjust these dates later. And it's 2007. Now I'm not going to define an end date at this particular time. We're just going to let it prorate forward. But we're going to come back and probably define an end date for it when we know when it should end. I'm going to click apply, and you can see here I now have a shifting bar here that's saying that this particular shift is in effect for this time. Now if we look at how we construct a shift, I'm actually going to pin this off to the side so we have a little more room to play with. So my shift manager is down on the side. We have various inputs and we have various shifts to those inputs. These are both values of stage. So this is essentially a stage value where I want to pull away from my base rating curve, and then the shift value is how much do I want to pull the rating curve apart from the shifted curve. So the inputs here of 0.1, it's the default value, but it's not going to match the stage values that I'm dealing with here. So the first input, probably useful to put that around 36.8, around the bottom of my curve, maybe 36.9. So I'll put that in as my first value. And I'm not going to apply a shift at this point, but now I'm going to turn on my second shift point, and it's going to go 0.1 up from me, so around 37. Now I actually want to go up to around 37.4, 37.5, because I know my shift is going to blend back into my base rating curve, essentially where I'd make a transition from section control to channel control. And we talked about that in the previous video. That's going to be about what my break point is. And if we look over here, my break point is 37.49. 37.4 is probably a good value to start coming back into the base rating curve at. Again, we can adjust these later. We're going to do most of this stuff visually. These are just some good starting points for us. A few other things in terms of adjusting the date and times associated with our various our shifts. You can start by changing the start times and end times. You can tell it to snap to specific values. So if you only know to within a day, you can tell it to snap to the nearest 24 hours. And all of this we can do down on the bottom here as well by adjusting that the dates of applicability. But let's go ahead and start developing this shift. I'm going to click here. I'm going to go back to the shift diagram over here, or sorry, not the shift diagram, the rating zoom 1. And we're going to look at shifting this curve out to hit these measurements 56 and 55, the ones of the scour condition. So let's rescale ourselves over here in the shift diagram. And the shift diagram is really where we're going to develop this rating curve, or the shifted curve. And you can see here the measurements falling above the rating curve and these measurements falling below the rating curve. And what we want to do is essentially pull our shift points out and split the rating curve at a certain point. And you can see I've done that right there. I've shifted away from the base rating curve to form that. And that's a very classic shape. That's called a knee bend. This is the hip, the knee, and the ankle down here. And essentially what I'm saying is I want the base rating curve above a certain point. I'm going to break away from it and do a smooth transition. And then eventually, we don't know any further below there, so we're going to apply a constant below that. And you can see what that shifted rating curve looks like right here. We'll look at it in log space. We'll just zoom in right there, and you can see I'm attached to the base rating curve at the transition, and then I go through those two measurements, and then I continue on down. So that's what that shift looks like. If we want to look at that in rectilinear space, we can do that as well. We'll have to zoom in quite a bit here just due to the scales. So let's zoom in all the way down at the bottom of the rating curve. And you see there, in rectilinear space, there are my two measurements falling off the base rating curve, and I'm adjusting my curve to that blue line that's going to fall away from them. And again, I join back in around the transition to section control. We can click on these measurements and have a look at the error and what we're dealing with. So the original error was 42.6%, but due to the shift, we're now within 2%, or 0.2%. For this particular measurement. Let's look at this one, measurement 56. Again, very small errors associated with them now due to the shifted curve. So that's very useful. We're going to go ahead and apply that shift forward in time. So what I'm going to do is go into my shift manager, and we're going to say, well, when is this shift going to be applicable until? Well, short of knowing anything in the middle, in terms of measurements, I'm going to say that this shift is probably applicable right about to the peak of the hydrograph. So let's say the peak of the hydrograph is probably just before October. I don't need to get the date exactly because I'm going to edit it visually. So let's say just enter October here. And if I click apply, you can see now the end bar associated with it right there. And if we zoom in a little bit on this, we can actually click the time adjuster to adjust the date. I click on that bar, and now I can just drag it back. And I can pick that peak right on. Now I'm snapping to the full day here because you remember in the shift manager I specified to snap to exactly 1 day. So I could say it'll go till midnight on that particular date, and that will be the shift that will apply in between that date and the end of that particular time. We'll do the scoured condition for the entire time. Now what are we going to do after that? We're going to want to shift in the opposite direction because we're going to assume at the peak of the hydrograph we start filling the control. The energy of the creek is going to start going down, and we're going to fill up the creek controls until we reach measurement 58 and 59, which are on the opposite side of the curve due to the fill conditions for them. So what we're going to want to do is go into our shift manager, and in this case we want a shift that's very much the same shape, but it's just in the other direction. So rather than entering all those values anew again, what I can do is use the handy clone tool, and I can click on the shift that I have and I'm going to clone it forward. And it says, do you want to clone this shift forward? Yes, I do. And let's pick a better color. Green is not a good color to start with. Well, actually we used blue before, and red is our base rating curve. Let's use maybe a purple or a violet. Maybe a dark teal. That'll be a good color. And we don't need to have to define an end date for this one yet. We'll come back to that. If I click apply, we now have that particular shift. But in this case, we don't actually want to shift in that direction because this particular shift, we want to shift out to measurements 58 and 59. So we're going to use the tools over in the shift diagram again to move ourselves across. I'm going to click and I'm going to grab shift point 2. I'm going to move it across. There we go. And you can see now I have a different shifted condition. And I go back to my zoom panes, and you can see once again I've now blended my base rating curve, again very much the same as I did up at the beginning, and I'm shifting out in the other direction. A knee bend style shift, but this time in the direction for filling up of the control, for aggregation of the control. And you can see my rating curve doesn't quite extend down far enough to hit measurement 60. So if we get back into base rating curve here, we can insert another row below this in my base rating curve table, maybe go to a flow of 0.01, and a gauge height for this is probably very close to my point of zero flow, which would be my first offset. So I think the offsets we're dealing with here is 36.7. Yeah, I can see it right there. That's the offset value, again from the rating development course we took. 36.71 is going to extend my rating curve back down to 0, and you can see there the extension of my rating curve and the shifted curve all the way back down. If I rescale my axes here, we're going to see a little bit more of the bottom end of the curve. So we've shifted in both directions now. We can look at the dates of applicability for those shifts. Let's move ourselves back out a little bit. Let's have a zoom here. And we can see for measurements 58, 59, and 60, we have the dates of applicability for that particular shift. Now, because we cloned that shift forward, it cloned it forward to start a day after this one started. So we may want to adjust this end date, and we can do that right here. We can just blend one into the other and just snack them up against one another. Now, one thing we may want to do in this particular case is if we don't know the exact date and time in between these two, we may actually want to prorate one shift into the other. Now, to do that, you use the shift manager, and for the first shift, rather than applying an end date where you know it finishes and applying the shift as a constant in between the two, you can click on here and not specify an end date. It's not going to change anything per se, but what it is going to do is take the shift as a constant right here, and it's going to prorate it forward until the next shift comes forward. And what we can do is actually have a look at what that curve looks like by using something called the time slider. If I click the time slider on, it gives me a purple line, and essentially it tells me what shift is in effect on that purple line, date and time. And if I move myself back into the first shift territory, say right here, you can see that I'm prorated inwards from these particular measurements. So I've time prorated. If I move the time slider again over here, you can see the shifted curve is in effect right there. So we actually get time proration in between. Now this is probably something we don't want to do in this particular case, just because now we've associated a true error with these measurements is actually quite large. So the shifted error when it was applied as a constant was very good, but now that we've prorated things, we have a true difference that's actually quite high. So I definitely want to go back in there into, let's see, my shift manager and apply an end date to this one. And we'll stick on an end date of 10. And it'll warn me, I think, if things are going to overlap. Yeah, the dates conflict, so I'm going to have to move this one back a little bit just to make sure. We'll go back to the 30th. Still conflicting. I need to look at my dates a little more closely. Let's go back to the 20th or so. And I can always move this forward. There we go. And let's just move that one forward now using the adjuster. We'll just snap that one all the way forward. Can't go any further. That's good. So now I've got it back to the original state. So that's the shifting of the rating curves. It's a fairly simple process. The type of shifts I've talked about here are the knee bend style shifts. These are very typical style of shifts for bottom ends of rating curves for section controls. When you're dealing with shifts to the higher flows, channel controls, they're generally due to things like weed growth or bank erosion that would typically be more permanent adjustments to the rating curve. So those would be generally temporary shifts as well until you have enough points built up to redraw the rating curve in a new rating curve and defining something new in terms of the rating period manager. So once we've got that complete rating curve, including all of its shift applied, now we can go ahead and start doing a computation with the rating curve. And that'll be the subject of the next video.